students, a very good morning to all you guys. कैसे हैं प्यारे बच्चों? In fact, it is good afternoon. How are you guys? कैसे हैं आप सब लोग? So most of you might be, having a hangover of the JEE mains exam कि सर अभी कुछ लोगों ने दिया है. Some people might be preparing for the, coming slot जो कि मार्च में आने वाला है. Some might be preparing for the April slot. But anyways, जिन लोगों का हो गया है और जिन लोगों ने अभी देना है बेटा, we will be coming up with some nice explanatory videos on the solution of these questions of JEE mains. जो भी पेपर अभी हुए हैं उनका डिटेल्ड सॉल्यूशन का वीडियोस हम लोग आपको प्रोवाइड कराएंगे. So we'll be providing these solutions on our YouTube channel of Aakash Digital, as well as on the Aakash Education channel. You can have a look at those. So, and I want, if you are going to the exam, you should watch what has been asked in slot 1 and slot 2. एक बार देखना जरूर चाहिए आप लोगों को, right? Anyways, so what is there for us today? Dear students, today we will be starting with a new chapter, hydrocarbons. दो चीजें पढ़ने वाले हैं, alkanes and alkynes, right? And as I told you, this is a live class. तो आप लोग अपने जो सवाल हैं, जो डाउट्स हैं, वो मुझसे पूछ सकते हैं. कैसे पूछेंगे आप लोग? How you will be asking me is that you will be asking me these questions on this WhatsApp number 9311883484. Okay. So if you got any doubts, you can ask this part. Also, we are running a career counseling series on the channel. I hope आप लोगों ने देखा होगा. It is running on every Sunday, and on 21st of February we had this program, how to score 250 plus in JEE mains. If you have not seen it, please watch it. It is available on the Aakash Digital YouTube channel also. Otherwise, repeat telecast तो आप देख ही सकते हैं, right? चलिए, without wasting time, because I have got a lot of things to teach today. बहुत सारी चीजें पढ़ानी है यार. So I am pretty excited. इसको आज खत्म करना है हम लोगों को. Fine. तो शुरू करते हैं. क्या करने वाले हैं हम लोग? Wherever I find a mechanism which is important, I'll detail out the mechanism. वो reaction कैसे हो रहा है? Fine. Wherever there is no mechanism but the reaction is important, has been asked, वो मैंने यहाँ पर लाया है. So the most important parts, in fact you will observe कि सर maximum तो आपने cover किया है, that will be covering maximum part of it, but still the one that I am going to cover is the most important part, right? चलिए शुरू करते हैं. So first is alkanes. I am starting with the preparation of alkanes, right? Now when I talk about preparation of alkane, the first one is reduction of alkenes and alkynes. अब देखिए reduction करने के लिए what we are doing is we are using hydrogen and nickel at a high temperature. Now this reaction is known as Sabatier-Senderens reaction. ठीक है? Now there are two ways to go ahead. First is, okay fine sir, हमने reaction देख लिया, we've seen the reaction, we have marked up the reaction, let us go ahead. Don't do it in organic chemistry. ऐसा कभी मत करना. Never ever do this, my dear students. Okay? What you need to do is just understand a bit of it. थोड़ा थोड़ा समझने की कोशिश करेंगे. What exactly is this? यार ये क्या दिया हुआ है? What is this H2Ni 573 Kelvin? हाँ, ये क्या है? So see dear students, ये क्या होता है? We basically take a nickel aluminium alloy. एक alloy है. Okay? What we will do is we will crush this alloy. We will crush this and convert it into the powder form. ये powder form बन गया बेटा? Fine. Now what we will do is we will sprinkle some NaOH on top of it. ये NaOH. We are going to sprinkle some NaOH over it. Now, when NaOH is passed over the powder nickel aluminum alloy, what do you get? You get nickel, on the surface of which you have got this hydrogen adsorbed. Okay, fine. Plus this is moving out. Okay. So, this is the nickel hydrogen, because you should need to think now, sir, hydrogen is a gas, nickel is a metal. So, how hydrogen gas and nickel metal can be brought together? So, this is how they can be brought together. This is the catalyst. Okay. So, instead of nickel, but all you can use platinum, you can use palladium. Okay. और आपको याद होगा, in the periodic table we have studied that nickel, palladium, platinum belong to the same group, also referred as catalytic metals. First thing, clear हुआ? Second, how is it acting? ये हो कैसे रहा है? So you see what happens is that, देखो बेटा, this is nickel, okay, and now hydrogen is adsorbed on the top of it. Agreed? Now this is the carbon-carbon bond. Now this, I am taking an alkene over here. So this is how the pi bond is also adsorbing on the surface of nickel. The pi bond is, or the alkene is adsorbing on the surface of nickel, hydrogen is adsorbing on the surface of the nickel. इसीलिए तो हम इसको catalytic hydrogenation भी बोलते हैं. We also call this as catalytic hydrogenation. Now what happens? This hydrogen and this hydrogen combines in that alkene or alkyne, and thus gives you the saturated hydrocarbon, that is alkane. Okay. Now as you can see, both the hydrogens are adding from the same side. So this addition is also referred as syn addition. This is also referred as syn addition. Clear beta? Fine. So now you have understood what is the purpose of each reagent over here. So alkene, alkyne, H2Ni, H2Ni. Why you are writing 2H2? Because for alkyne you will be requiring to break 2 pi bonds and thus add more hydrogens, right? Okay, clear? Chale. So this is how you should be, I think. Now this, with the help of this reaction, what all I am telling you is how you have to study organic chemistry, the reactions part basically. So when you read a reaction, you should be knowing something about it. It's not always so that you will be having such detailed mechanism, but as many as possible, जितना हो सकता है उतना तो करेंगे हम लोग. Okay. Now next one is from alkyl halides by reducing. Now over here we are saying by reducing the alkyl halide. Now what is the meaning of reduction? So over here we are saying the reduction basically means that we are adding hydrogen. Now if you talk about organic chemistry, this word adding is wrong. ये word adding wrong हो जाता है. आप बोलेंगे sir why adding is wrong? Because in this organic chemistry part, addition reactions refer to those where we are adding something to the unsaturated species. जहाँ पर भी, wherever you have got a carbon-carbon double bond or say carbon-oxygen double bond, there if you are adding something, we call those reactions as the addition reactions. But in general, if you pick up the physical chemistry portion, so what is reduction? This is an addition of hydrogen. So basically over here what will happen is, let us see what is alkyl halide. You see over here, you see this reaction over here beta. You see that this is Rx and this is H2. So what is happening basically? This hydrogen combines with R and X moves out. So you will say sir this is more like substitution. Exactly. Okay? So see these words should be very very clear in your mind. So if you are coming from the physical chemistry thought process, you will say sir reduction is addition of hydrogen, reduction is removal of oxygen. Not always oxygen, it can be an electronegative atom also. So it is removal of halogen. Okay. So if you look at it from the organic chemistry perspective, it is more of a substitution. X goes out, H comes in. ठीक है बेटा? Is this point clear to you na? Okay. So do not get confused if I say add basically. So in reducing or in reduction processes, basically one of the ways when I'm talking about alkyl halides, specifically, मेरी बात को please ध्यान से सुनिए. In the previous case, over here also we were adding hydrogen. This is addition. This process is not only addition, it is a substitution. You are taking away the electronegative atom, adding the electropositive atom. ठीक है? So this is a difference. So confusion नहीं होना है. You should not be confused at all. Okay? So what basically do we require? In any case, we require hydrogen. We require hydrogen. So what is the meaning of this zinc couple? इसका क्या use है? What is it going to do? Nothing. When they combine up, they will give you CH3 COO whole twice Zn plus 2 nascent hydrogens. Okay, fine. So now how this reaction is going to take place? You will have R, X, and you have H and H over here. So R combines with H, X combines with H. So this is how the reduction has actually taken place. As simple as that. Understood? Clear? So same way, over here what do you get? You will be getting ZnCl2 plus nascent hydrogen, NaZnO2 plus hydrogen. Zinc copper couple basically is, when you are, couple basically means you are electrolyzing it. Okay, you are using an electrochemical cell. Similarly, aluminium mercury couple, herein we are considering that they are dipped in an aqueous solution or water is there. So from which the hydrogen gas is getting liberated. Okay, so whenever they say couple, समझ लीजिए that you basically are talking about an electrochemical cell. It will be an electrolytic cell wherein the gases are being released out. So the hydrogen gas gets released and that hydrogen is basically used for reduction purpose. Clear? Okay. So this is point number 1, that what is the use of all these reducing agents, how this reduction is done, right. Now the next point is that when we specifically talk about alkyl iodides, we are using HI in red phosphorus under high temperature and pressure. So now the question arises, why? Why we are not using all this? See, the point is this iodine which you are forming over here, this iodine is basically, it has to be removed out by using this red phosphorus. So what we do is that this iodine combines with the phosphorus to form 2Pi3. So that is why we are using red phosphorus and HI as a reducing agent. In fact, it is a very strong reducing agent. Okay, fine. You'll ask me, sir, why not all those things? See, beta, this Ri, I mean alkyl iodide, the point is that this alkyl iodide, when you are trying to reduce by any of the above said method, the only problem is that the efficiency of the process or the yield, the amount of product which you want to obtain is slightly less. So that is why we are using this particular specific process to get a higher yield. In fact, this is a highly effective process, and you will observe that in the coming reactions we are talking more about this. देखते हैं. Now the next is name reaction, Wurtz reaction. All such reactions should be very clear with all the ifs and buts. इसमें क्या हो सकता है, क्या नहीं हो सकता है, right? So first of all, you all know this part that basically you take alkyl halide and reacted with sodium. But now question number 1. Why are we using dry ether? We are using dry ether because the Na combines Na plus water. This is an explosive reaction. This reaction is explosive, and this will give you NaOH plus hydrogen gas gets liberated out. So we don't want that thing to happen, so that is why we are using dry ether. Clear? How this reaction will take place? So there are two alkyl iodides, so I am writing it like this: Ri plus 2Na plus IR. So what will happen is that Na moves out and this R combines with R. Now we are saying that it goes by the Free radical mechanism means R and I break off with their 1 electron each and sodium combines with iodine. This R free radical combines with R free radical. So, we are talking about a free radical mechanism over here. Okay. Now, this is good for symmetrical alkanes. You will ask me, sir, why? Suppose if you are taking two different alkyl halides, suppose you are taking CH3X plus 2Na plus C2H5X. The problem is that you will get the ethyl radical, you will get the methyl radical. So, ethyl can combine with ethyl, form butane. Methyl can combine with methyl, form ethane, and methyl and ethyl, they can also combine to form propane. So, you will get a mixture of products. So, sir, what is the problem? The problem is that when you are getting a mixture of products, you have to purify them to get the one which you actually want. Say for example, you go to a petrol pump and you say, Bhaiya, I fill the tank with petrol, and he says, sorry, today I don't have pure petrol, I have got a mixture of petrol and diesel. Do you want to take? Will you take it? I said, no sir, engine kharab ho jayega, the engine will go out, right? So you cannot add diesel to a petrol engine or petrol to a diesel engine, right? So he'll say, oh, you don't worry, why don't you purify, separate each. So do you think it is an easy process? No, it is not an easy process. So that is why we do not use this process for to get the unsymmetrical alkane. We talk about the symmetrical alkane. Okay. So that is why, as it is written, it is not a good method for unsymmetric alkanes. Okay. Now also methane cannot be formed. See, all these points are important. Why dry ether? Which mechanism? Can it be used for unsymmetrical alkane? Can methane be produced? These are the four important things from which they will ask the question. Nobody will ask a question saying Rx plus 2Na plus Rx is which reaction? Nobody is going to ask that part. This is what they will be more interested in. Fine. And the fifth important part is what is the order of reactivity. Since we are talking about a free radical mechanism, how easily the free radical can be formed. So, over here Ri, then Rbr, then Rcl, then Rf means higher is the bond length, easier it is the bond to cleave. So, this shows a higher reactivity towards the Wurtz reaction. So, 5 question important hoga. Now, second important thing that I am telling you over here. When you are given a reaction, a name reaction, please don't simply remember it. Ki Wurtz reactions are. There are certain points. Why dry ether? Which mechanism? Free radical. Can we produce unsymmetrical alkane? No. Can we produce methane? No. Why not? Because we get a mixture of products. What is the order of reactivity? This is the order of reactivity. This is how you will be able to make your notes properly. बच्चे होते हैं मैक्सिमम कहते हैं कि सर ऑर्गेनिक केमिस्ट्री डिफिकल्ट हो जाता है. दिस इज व्हाई इट बिकम्स डिफिकल्ट बिकॉज दे जस्ट मग अप द रिएक्शंस. डोंट डू लाइक दैट. ओके, चलिए नेक्स्ट वन. अनदर पॉसिबिलिटी दैट इफ यू आर going for a Franklin reaction, it is similar to the Wurtz reaction. The only difference over here is that you are very specific. It is a name reaction. So, and we are talking about Ri. So, only the alkyl iodide on reacting with zinc will give this particular reaction. Please remember. So, this is a name reaction mechanism similar to that of the Wurtz reaction, but a very specific reagent based reaction. Okay. Now, reduction of alcohols, as I told you that red phosphorus and HI is a very strong reducing agent. So, now you can see we are reducing alcohols, we are reducing aldehydes, ketones, fine. So, all these we can reduce by using red phosphorus and HI. Carboxylic acid, all can be reduced by using red phosphorus and HI. I am just denoting the reaction over here. You need to remember that when you use HI, HI is a strong reducing agent, it releases the nascent hydrogen. Okay. Now, this nascent hydrogen combines with the R, so you get RH. It combines with the OH, so you get H2O. Fine. So, how many hydrogens do you require? You will say, sir, one hydrogen basically is required for R, one hydrogen is required for OH. So, basically I require 2 hydrogen, that is why you are writing 2HI. Now when you are having 2HI, you will be getting 1 mole of iodine. Okay. Now this iodine will combine with red phosphorus, will give HI once again. Now this HI can be reused in this reaction. Okay. The same way we can do for aldehyde ketones carboxylic acid. Some more name reaction for aldehyde and ketones that you need to remember, beta. See this one. This is, when we are reducing in the presence of zinc amalgam in the HCl, it is referred to as Clemenson's reduction. The idea is same, you will be getting zinc chloride, mercury chloride and nascent hydrogen will be released out. Okay, fine. This 2H2O that is written is for illustration purpose. Actually it should not be there because this hydrogen will basically come from this. So you are not actually passing some hydrogen gas. So please do not get confused. Okay. So RCHO when passed through zinc HgHCl, you will get this. No need to write this H2. I have written this intentionally because many a times I have seen students writing it out like this. You are not passing hydrogen gas, pyare bachcho. You are not using a hydrogen gas. Hydrogen comes from this zinc amalgam HCl. This is the reducing agent, and this reaction is referred to as the Clemenson's reduction. And now see, Wolff-Kishner reaction I have written the right way. This is a Wolff-Kishner's reduction. Herein you take this aldehyde, pass it through hydrazine and then alcoholic KOH, or you can also use glycol and you will get the alkane. Okay, so do not write like this. So what is the difference between Clemenson's reduction and Wolff-Kishner reduction? That one is using zinc amalgam in the presence of HCl, second is using hydrazine in presence of alcoholic KOH. In both the cases, you are getting hydrogens which are get added over here. Clear? Okay. Next one. Now from carboxylic acid, so we are using HI and red phosphorus. Already we have talked about this part. What is the next method? Next is important. This is decarboxylation. What is the meaning of decarboxylation? Decarboxylation means removal of this carbon dioxide. That is D. D means removal of carbon dioxide. How we are going to remove it? By using NaOH and CaO, which is referred as, so this is NaOH is soda, CaO is lime, by using soda lime. Okay. So when you use soda and lime, the decarboxylation takes place and you get the alkane plus Na2CO3. Sir, how does it takes place? I am just giving you a brief hint. Honestly speaking, you don't require to talk a bit about anything about the mechanism over here, but just for your understanding sake, dekho. This is the carboxylic acid salt. Okay. To this you are adding NaOH. Okay. I am just giving you a brief of what it is happening, not giving the exact mechanism. Okay. I am not giving the exact mechanism, repeat kar raha hu. So now see, this NaOH is attacking over here. Okay. So now what happens is, when this NaOH attacks over here, this R moves out and this R minus combines with this H. Thus you see R and H are combining to give RH. And now see, Na, there are two NAs, one carbon, 1, 2, 3, 3 oxygens. See, this is what you are getting, RH plus Na2CO3. You will ask me, sir, NaOH to theek hai, but what is the use of CaO? See, CaO is helping, because this is a base, this is helping this hydrogen to be released from here. This is helping this hydrogen to be released from here. Okay. Now, you can ask me, sir, theek hai, hint you have given, but isn't it happening like this? No, it's not happening like this. But actually, when you say RCO minus ion, what happens is that we need to move this R minus from here. So this is something how the R minus takes place. You get the carbon dioxide combines with NaOH and CaO, and then Na2CO3 is released out. But as I said, no need for going into the detailed mechanism aspect of it. Hint I have given to you. Now you understood. Okay, fine. This is the use of NaOH. This is the use of CaO. Okay. You might also feel, sir, acha, in which cases do we require full mechanism, in which cases we require hint. See, wherever a mechanism is required, I will give you the mechanism. Wherever a mechanism is required, I will give you the mechanism. Wherever mechanism is not required, for better understanding, if I can give you a hint, I will give you a hint. Okay, fine. Now, next is Kolbe's electrolysis. So, over here also we are using a carboxylic acid salt. Okay, and we are taking aqueous solution and doing the electrolysis. So, this is what we are getting. Now, see, I can give you a good mechanism over here. Okay? Here I can give you. Now, at anode what is happening? See, CH3, CO. Now, oxygen is having 1, 2, 3, 4, 5, 6 electrons, right? But it is taking one electron from what? It is taking one electron from sodium. So, this is the electron, the green one. Okay. Now, you are having 2 moles of it. What happens at anode? You will say, sir, at anode oxidation takes place, right? So, minus 2 electrons, and this will give you 2 CH3 COO and 1, 2, 3, 4, 5, 6. Okay, and plus what you are going to get is, I mean, these are the 2 electrons that have been moved out. Okay. Now, this is step number 1. Now, what happens? This is very interesting. See, dear students, if you observe, this is a free radical. This is a free radical. Now, those who do not know what exactly is a free radical, sir, pata hi nahi hai what exactly is a free radical. So, if you are having a free electron, so, sir, here there are 1, 2, 3, 4, 5. Which one is free? See, beta, this is a pair. This is a pair. This is paired over here. Only this electron is free. So, that is why it is referred as free radical. So, the larger or the bigger free radicals break into smaller free radicals. So, how? You see? In fact, isko bhi na ऐसे नहीं लिखते हैं. It will be more clear if I write like this. Helpful for the future reactions. So, 1, 2, 3, 4, 5, 6. 1, 2. Okay, this is how the electrons are being shown. Now, see what happens. This electron and this electron combines up. This is how it will break, and it will give you 2 CH3 free radicals plus 2 carbon dioxide. देखो, अच्छा, some people would say, sir, why you are writing CO2? अच्छा, चलो ठीक है, CO2 नहीं लिखते हैं for your better understanding. Let me write it like this. C double bond O double bond O. Okay, and this is CH3, so this is the free radical. ये तो समझ में आया ना, ये चलेगा, this will work. Okay, now this two CH3 free radicals will combine with each other and will give you the ethane. Carbon dioxide, as it is written over here, right? Now you have got Na. So, this Na plus combines with water and will form NaOH and will release the hydrogen gas at cathode. Okay. So, this is the mechanism of Kolbe's electrolysis. So, you require it, I have told you. ठीक है, समझ में आया? Right. Now, let us move ahead, beta. But one more point, can you prepare methane from this? The answer is no. So, I am writing it over here, methane cannot be prepared by this method. Okay. Achha, it was we were not able to prepare methane from Wurtz reaction also, Franklin reaction also, even from reduction also we were not able to prepare. So, sir, किससे prepare होगा? How we can prepare? अभी बताया ना, I told you right now, decarboxylation. See, if you use CH3COONA, NaOH, CO, see you will get CH4. So, by decarboxylation methane can be prepared. So, now what will they ask? They will say which of the following methods is used to prepare methane? First, Wurtz reaction. Second, soda lime decarboxylation. Third, reduction of alcohols. Fourth, Kolbe's electrolytic method. So, the answer is soda lime decarboxylation. I am using the word specifically, soda lime decarboxylation. Clear? Okay. Now, let us go ahead. Now, the next is by using Grignard reagent. Now, those who do not know, sir, Grignard reagent क्या होता है? See, this is say R. For R, I am using the carbon, a metal like magnesium, and a halogen, maybe bromine or chlorine or whatever. So, the interesting part over here is that this magnesium is having a +2 charge. This halogen is having a minus charge, and this carbon is also having a -1 charge. So, you can get a carbon ion from here. You can get a carbon ion from here. That is the beauty of this Grignard reagent. तो अभी देखो क्या होगा. Whenever you see Rx plus Mg in the presence of dry ether will give you RMgX. Okay. Now, whenever you see this RMgX, you should see it like this, R minus and Mgx plus. So, now see this R minus is looking for H plus. The moment it will get H plus, it will form alkane. So, देखो अभी. See over here, this R combines with this H. Okay, fine, you are going to get RH. Here it is combining with this H, here it is combining with this H, here it is combining with this H. So, you get RH, and now see Mgx. What is the remaining part over here? OR dash, MgORX. What is the remaining part over here? R dash NH, R dash NH. Remaining part OH, OH. Remaining part CC, R dash. Got it? So, it is looking for that acidic hydrogen, the H plus that it can take. Okay? Because R minus ion is a very strong base. So, it can easily, some students might think, sir, it is reacting with water. Yes, it reacts with water because R minus is a strong base. It can take out H plus from even water. Okay? And see, that is why I have written over here, any compound having acidic hydrogen atom decomposes the Grignard reagent. So, this is how you can get alkanes. Understood? Okay. Now, next is by action of water on aluminium and beryllium carbide. See, this primarily you study in the inorganic chemistry portion, but still I have put it up over here that by adding water to the carbides you can get the respective alkane. Like over here, aluminium carbide, beryllium carbide, I am getting methane. Fine. So, I am very specific, only methane is found by this reaction. So, we had a problem now, how methane is being formed. See. Okay. Now, the next is, this is important, by lithium dialkyl cuprate. It is also known as Corey house synthesis. Corey house synthesis. Sir, ये क्यों पढ़ा रहे हो? What is the use of this? With the help of this process, I can get unsymmetrical alkane. भाई एक problem था ना, in Wurtz reaction, see, if you are talking about hydrogenation of alkene, yes, you can get unsymmetrical alkane, first process. But reduction of alkyl halides, yes, you can get unsymmetrical alkane. What about Kolbe's electrolytic method? No. What about decarboxylation? Yes, you can get unsymmetrical alkane. What about Wurtz reaction? No, you cannot get unsymmetrical alkane. By this method, you can get unsymmetrical alkane. So, the benefit of this process is, okay. So, first we will do is we will take an alkyl halide and react it with lithium, okay. So, you are going to get RLI. This is, what is this? Organometallic, means a bond between carbon and a metal. Now this RLi combines with CuI to give you lithium dialkyl cuprate. It is also known as the Gilman's reagent. R2CuLi. It is also referred as the Gilman's reagent. Now this Gilman's reagent, when it combines with another alkyl halide. Now here you can use anyone. It's your wish now. अब आपकी मर्जी है. Not necessary you will be using this R. You can use this R dash. It can be any other. Suppose instead of over here it is methyl, but over here is ethyl, right? And thus you can get this unsymmetrical alkane. But there is an important point over here, that R can be 1 degree, 2 degree, 3 degree alkyl, or even the aromatic group, but R dash should be 1 degree, 2 degree psychoalkyl or aromatic group. Means this R dash should not be 2 degree or 3 degree. It should be only either 1 degree, 2 degree cycloalkyl or aromatic group. In fact 3 degree, 2 degree maybe you will get to some extent the product, but 3 degree it should not be, because if you are having a 3 degree alkyl halide, it might lead to the elimination process and you can get an alkene. इसीलिए, ठीक है. So this is known as the Core-House synthesis. Got it? Understood? चलिए. Now let's talk about the chemical properties of alkane. देखो बेटा, alkanes जो होते हैं ना, they are also called as paraffins. Alkanes are also called as paraffins. Paraffin का मतलब क्या होता है? What do you mean by paraffin? Paraffin means low reactivity. Why the reactivity is low? Because they are not polar. There is no plus minus charge, no effects are working over here. So that is why what you will observe is, you will see that these are undergoing reaction under drastic conditions. Okay. Now this is a free radical halogenation. So if you observe, we have taken this methane, this is the halogen in the presence of light. This is a free radical reaction. Let me write over here. It follows the free radical mechanism. Okay. And for free radical you require help. Now what is help? You require heat, you require electricity, you require light. Light is given by H nu. Electricity I can show like, how to show? Can I show like this? Okay. P is peroxide. So heat, electricity, light and peroxide. Electricity we have used Kolbe's electrolytic method. Light we are using over here. Peroxide, yes, I'll show you the reactions in the coming, in the coming slides. Okay. So now what is happening over here? It is a chain reaction, will happen step after step, step after step. So you see, first hydrogen is substituted. In fact, it is also referred as the, let me write by using this color. It is also referred as the free radical substitution, because hydrogen is substituted by halogen. So this is free radical substitution. Okay, beta? Huh? First hydrogen is substituted, then second one, then the third one, and finally the fourth one. So it is a chain reaction which keeps on going ahead. Now you will say, sir, what if I want only mono substitution? What if I want mono substitution? So see, what you will do is, if you want mono substitution, what you will do is, you will take CH4 plus Cl2, 1 equivalent, means chlorine is the limiting reagent. So you will get CH3Cl plus HCl. What if you want complete substitution? So you will say CH4, 1 equivalent plus Cl2. So now over here methane was in excess, over here chlorine is in excess, and you will be getting CCl4. Got it? Understood this part? Now one important point which I would like to tell you regarding the free radical mechanism. See, when you talk about free radical mechanism, there are three important steps. The first one is chain initiation. Like in this case, I am saying Cl2 in the presence of H nu is forming Cl free radical. Okay. Now this Cl free radical combines with CH4 and is giving you CH3 free radical plus HCl, like this. Okay. This is how it will proceed ahead. So this is referred to as the chain propagation. So first free radical of the carbon chain has been formed. Now it will propagate. So CH3 free radical combines with Cl2, gives you CH3Cl plus Cl free radical. Now this Cl free radical combines with CH3Cl will give you CH2Cl free radical plus HCl. So this is how this chain propagation will keep on happening, but the important point over here, my dear students, is that there are two important points. First, each step is exothermic. This is very, very important. And second, new free radical is formed in each step. New free radical is formed in each step. ये आप लोगों को ध्यान में रखना है. Okay. Two most important point about chain propagation. Third is the chain termination, where whatever free radicals are left out, they will combine with each other. But only because of this chain termination step, we never consider free radical mechanism for any conversions. Exam में होता है ना, that A reacts with B to give C, or या फिर from A you form say B, how you will convert? You will never ever use the free radical mechanism in between, or free radical substitution should not be preferred. Reason, because when you are talking about chain termination, a variety or a large number of products can be formed. याद है, we talked about Wurtz reaction. So we said now we were getting butane, ethane and propane also. We get mixture of products. Here we get a mixture of products. That is why it is not considered a good process even industrially. Even in industries, it is not considered to be a good process. Okay. So these are the three important steps: chain initiation, propagation and termination. Fine. So now you are clear with the free radical mechanism. So free radical mechanism clear, free radical substitution clear, because hydrogen is substituted by halogen. Okay. Now some specific things. When you talk about iodine, what you observe is that this reaction is reversible. Why? Why is it reversible? Because this Hi is strong reducing agent. This is a strong reducing agent. So what we need to do? We need to somehow oxidize this Hi. So this reaction is possible if you are using oxidizing acids like HiO3, H2SO4, HNO3. They can oxidize this Hi to I2. Okay. Otherwise this reaction will be reversible in nature. Okay. Next point. Alkyl fluorides are more conveniently prepared indirectly by heating suitable chloroalkanes with inorganic fluorides such as this. Though I will be repeating this part in the alkyl halide portion, but you need to understand that here we are producing alkyl halides, but alkyl fluorides cannot be conveniently prepared by this method. That is why we are using inorganic fluorides, and this is how the reaction is actually taking place. Just for your understanding, I will come back to this Schwartz reaction once again. Okay, we will come back. You just need to remember that do not prepare alkyl fluorides by this free radical substitution reaction as we have done. Do not write CH4 plus F2, okay, not required. Now, some more important points over here. Ease of halogenation. See, in any alkyl group you can have a 1 degree hydrogen, 2 degree hydrogen, 3 degree hydrogen. So, the 3 degree will go for halogenation easily as compared to 2 degree as compared to 1 degree. Reactivity of halogen, fluorine, chlorine, bromine and iodine. Now, you will ask me, sir, fluorine is the most reactive. Why you are not using fluorine to prepare the alkyl fluorides over here? I am not using fluorine because fluorine is the most reactive. So, what? See, if I use fluorine over here, even with a small quantity, it will try to substitute all the hydrogens. So, it is very hard for us to control. You will get the products like in one you will get CH3F, then CH2F2, then CH3, then CF4. A mixture of a variety of products will be obtained because fluorine is highly reactive. Got it? समझ में आ गया बेटा सारा point? So, in this reaction what is important? It is a free radical mechanism. Point number 1. There are 3 steps in free radical mechanism: chain initiation, chain propagation, chain termination. What is important in chain propagation? Every step should be exothermic and a new free radical should be formed in each reaction. Can I prepare alkyl iodide by this method? No. Why? Because the HI formed is strong reducing agent. So, what I need to do? I need to use a strong oxidizing acid like HiO3. Okay. Can I produce alkyl fluoride by this method? No. Why? Because fluorine is highly reactive. Okay. Sir, all the hydrogens react equally? No. What is the order? 3 degree, 2 degree, then 1 degree. All the halogens reacts the same way? No. It is fluorine, chlorine, bromine and iodine. Okay. All these points are important. And this is what your note should be. Okay, beta? Let's go ahead now. Next is cracking or pyrolysis. Pyro means heat, lysis means breaking. If you take a bigger alkane and heat it at high temperature in the presence of a catalyst, you will get the respective alkenes. Okay, this is referred to as the pyrolysis. Not much of a mechanism is required. It is simply heating and breaking the bonds. Next is aromatization. You will normally see this aromatization with 6 or more carbons. So, if you are taking an say a hexane in the presence of Cr2O3 and Al2O3 at high temperature and high pressure, you will get benzene. And now, benzene is an aromatic compound because it has got conjugation and it follows the Huckel's rule of 4n plus 2. Fine. Let me just write it down. Aromatic compounds are those which are planar, which have conjugation means alternate presence of single and double bond, which follow the 4n plus 2 pi electron rule, that is Huckel's rule. Sir, what do you mean by this? See, when you look at benzene, how many electrons do you see, beta? This is 6 electrons, 6 pi electrons. Okay. So, if I take n is equal to 1, don't you think it will be 4 into 1 plus 2? How many electrons are there? 6 electrons. Okay. So, benzene is aromatic in nature, and now you understand what is the meaning of 4n plus 2? Huh? Okay. It is a planar molecule, lies in one plane. Conjugation, see, double bond, single bond, double bond, single bond, double bond, single bond, double bond. This is conjugation. So, these compounds are referred to as aromatic. Okay. Next is isomerization. So, over here when you are heating in the presence of AlCl3 and HCl, the straight chain compound forms a branch chain compound, and this is referred to as the isomerization reaction. All these are done under high temperature and pressure conditions because alkanes are paraffins. Understood? Okay. So these are some of the important properties of alkanes. Now we have to talk about alkenes. Alkenes have a general formula CnH2n. You know that part. Now let's start with the methods of preparation of alkenes. First and foremost, dehydration of alcohol. What is the meaning of dehydration? D means removal, hydration means water, removal of water from alcohols. Okay. So what all reagents we are going to use? We are going to use concentrated H2SO4 or H3PO4 at a high temperature of 170 degree Celsius. Okay. Now I am having some questions over here for me. These questions are I think you have shown me the wrong chat, Rajinder ji. Show me the one. ये biology के questions हैं. This dear student, you can ask. Can you go to that one? अनुष्का ने एक डाउट पूछा है, सर प्लीज एक्सप्लेन द मेजर प्रोडक्ट इन पायरोलाइसिस. ओके अनुष्का, आई गॉट इट. यस अनुष्का बेटा, आपने सिटी मेंशन किया है. फ्रॉम विच सिटी यू आर? अनुष्का, यू आर फ्रॉम विच सिटी? एनीवेज, तो अनुष्का बेटा, व्हेन यू आर टॉकिंग अबाउट पायरोलाइसिस, the simplest possible alkene would be a major product, but it depends upon what reactant you are taking. Say for example, if you are taking butane, so when you are taking butane, you can get ethene, you can also get propene, but it will always be easier for butane to break into two ethene molecules, because if you make propene, so what will happen to the rest of the carbon? Nahi banega na. But if you are taking pentane, suppose, then the possibility is the formation of a propene and ethene. Suppose you are having hexane, then you can get 3 ethenes. You can get 1 butene, 1 ethene, or you can get 2 propenes. All these are the possibilities, and that is why these are not considered as a very good reactions, because you get a variety of products. Achha, Anushka is from Delhi. I hope Anushka your doubt is cleared. Great. Fine. Some kids are doing a missed video call. Beta video call वगैरह नहीं entertain हो रहा है. Only and only WhatsApp is being catered. जैसे अनुष्का ने पूछा ना doubt, just from the topic which is going on. This is how you should be asking the question. Sometimes, हमेशा हम लोग नहीं करते हैं, but sometimes we also project these classes live on our YouTube channel of Aakash Digital. हम कई बार उस पर project कर देते हैं. So many students have read the chat, many students are asking over there, sir, is this a live class? Achha, we tell them again and again, beta, we are not reading the YouTube chats, हम उसको नहीं पढ़ते हैं, right? नहीं सर मेरा ये क्वेश्चन है, बेटा हम चैट नहीं पढ़ रहे, आप व्हाट्सएप पर पूछो. नहीं सर मेरा ये क्वेश्चन है. I don't know why people do like that. Simple है यार, एक व्हाट्सएप नंबर दिया, उस पर व्हाट्सएप करना है. अच्छा, कुछ बच्चे बड़े जोश में आ जाते हैं. Some people are like, सर ये रिकॉर्डेड क्लास है. And they are like, they use slang. भाई मैं बोल रहा हूँ ये रिकॉर्डेड है. बेटा रिकॉर्डेड, पहली बात तो मुझे लगता है कि any student can check for himself or herself whether it is live or not. हाँ, उस पर लिखा भी आ रहा होता है. Second case, यार तुम्हें ज्ञान से मतलब है या लाइव या रिकॉर्डेड से मतलब है? I am really surprised. You are getting some high quality, classes. उसमें भी झगड़ा, उसमें भी नुक्ताचीनी. Surprising. Okay, Anushka says, got it sir, thanks. Great beta. You can ask any number of doubts pertaining to what we are doing right now. Okay, chaliye. So, we are talking about dehydration of alcohols over here. Removal of water is dehydration. We can use strong acids. These are dehydrating agents. I mean, concentrated H2SO4 is a dehydrating agent. It will absorb, suck out the water. Similarly, H3PO4 at high temperature. Or you may use alumina, that is Al2O3 at high temperature. Okay, so they'll take out the water molecule and will form the alkene. Now see, this is the alcohol. You take out the water and you form the alkene. अब देखिए, over here, I can give you the mechanism which we can also pick up when we are talking about properties of alcohols. दोनों जगह आप pick कर सकते हैं. Fine, we'll do it over here. क्या issue है? So in the step number 1, I am having this H2SO4. This H2SO4 will give me one H plus HSO4 minus. Okay. Now, this alcohol will be attacked up by this H plus, because oxygen is having a lone pair which will be attacking this H plus. Okay. So, you will be getting R CH2 OH2 plus. Okay, fine. And now this oxonium ion, this is oxonium. Okay, will move out, giving you R CH2. In fact, I think I should change it over here. Yes, plus. Okay, plus water molecule. Now, I'm instead of writing the third step, I'm showing it over here only. Now, what happens? See, if you remember, I told you in the mechanism part, hyperconjugation. What is the condition of hyperconjugation? This carbon is sp2 hybridized, this carbon is sp3 hybridized, and you are having at least one hydrogen. So, now this positive charge will pull this carbon hydrogen bond, sigma p overlap will take place, and thus you will be getting R CH double bond CH2. Okay, fine. And this H plus will be taken up by H2SO4. Okay, and you require high temperature because a lot of bond breaking is happening over here. This is the mechanism for dehydration of alcohol. Fine. Now, this is considered to be a very simple thing because exams में इतना आसान भी नहीं पूछते. But what else can be there? See, you are getting a carbocation. Rearrangement of carbocation take place. Second, you can apply Saytzeff's elimination rule over here. Hoffman's elimination rule. क्या होता? I'll tell. अभी थोड़ी देर में बताऊंगा आपको. Also, if there is a cyclic, I mean a ring attached over here, so the ring expansion can take place over here. So there are a lot of possibilities which can happen, but अभी नहीं बताएंगे. Otherwise, you will be like, sir, so much is coming to our way. धीरे-धीरे करके will raise the level. Okay. सबसे पहले तो यही समझना था. The one that you have to understand is how to actually pick up organic reactions. Slowly and slowly, I will be enriching the content. Okay. ये clear हो गया? So now I told you wherever the mechanism is present, I'll explain the mechanism. So this mechanism is clear to you. Now, the question that can be asked to you, they will not ask a question directly from the mechanism. They will try to twist it. Twisting, I'll discuss because as I told you, rearrangement, Saytzeff's, ring expansion and all. That is one part. Next part, which alcohol will undergo dehydration easily? So the 3 degree alcohol followed by 2 degree followed by 1 degree alcohol will undergo dehydration. This is the order of dehydration. Sir, why? Because what do you mean by 3 degree alcohol, beta? 3 degree alcohol is this one. This is the 3 degree alcohol. So why should it undergo dehydration? Beta, because when this OH moves out, this will become a 3 degree carbocation, and 3 degree carbocation is more stable than 2 degree, which is more stable than 1 degree. Understood? Okay. Chaliye. Fine. Now, as I said, we will be talking a bit more about it. So, see over here, I am saying that this dehydration of alcohols follows the Saytzeff, or also known as Saytzeff's elimination rule. Saytzeff, same person, a difference in pronunciation. Okay, Russian, Indian. Okay, So, we are saying that the dehydration of alcohols follows Saytzeff's elimination rule. The major product will be Saytzeff's elimination product and the minor product will be the Hofmann elimination product. Sir, ये क्या होते हैं? What are these? Why is it so? Okay. अब देखो बेटा. Suppose we are having H CH CH2H. So this is the alcohol that we are having. Okay. Now a few points. See, from here we are going to remove out this OH. Agreed? Let us give it carbon number 1. We are going to remove hydrogen either from here or here. So that will be carbon number 2 or also referred to as beta carbon. So there are 2 beta carbons. If you remember, I talked about beta elimination. So why is this beta elimination? Because the hydrogen is moving out from the beta carbon. Okay, fine. So 1,2 elimination, beta elimination is clear. Now if you remove out the hydrogen from this beta, this beta, suppose I am writing it as beta 1. So you will be getting the product as CH3 double bond CH2. Whereas if you are removing from beta 2, you will be getting this. Okay. Now dear students, what you have to observe is, you have to observe this part. See, this is the double bond. Now in the basic double bond, alkene is this. ये क्या है? This is ethene. If you remove this hydrogen and put up an alkyl group, we call it as substituted alkene. What do we call it as? Substituted alkene. So over here, how many substitution you are seeing? You are seeing 1 substitution, 2 substitution and 3 substitution. Okay. Whereas over here you are seeing only 1 substitution. More substituted alkenes are more stable. More substituted alkenes are more stable. We will talk about the stability, but because I have taken this example of CH3, so we can also consider the number of hyperconjugations, though the concept is of heat of hydrogenation. Concept is of heat of hydrogenation means when we add hydrogen, what is the amount of heat released. Okay. On the basis of that we explain the stability, but over here abhi for the time being, because I have used CH3, let us talk about hyperconjugation also, because वो मैंने पढ़ाया हुआ आपको. So if you see this carbon, it is attached to 2 CH3, so 3 no bond resonating structure from here, 3 from here and 3 from here. Total 9 no bond resonating structures can be formed over here, but over here how many no bond resonating structures can be formed? Only 1. Only 1 NBR can be formed from this. So larger the number of NBRs, more is the stability. So this is a more stable product, and that is why it is called as the Saytzeff's elimination product. This is major. This is Hofmann's elimination product, considered minor. Okay. Oh, sorry. Yeah. Now, what is Saytzeff's elimination rule? Sir, rule क्या है? What exactly is the rule? Though we will talk about in alkyl halides also, but I am giving the simplest possible rule. The simplest possible rule is the poor gets poorer. Sir, ये क्या है? देखो बेटा, what do I call as poor? See, this carbon is having 2 plus 1, 3 hydrogens. So I am considering that one hydrogen is equal to 100. So this carbon is having 300 rupees. But this carbon is having only one hydrogen. So this is having 100 rupees. Which one is rich? The one which is having 300 is rich. Which one is poor? The one having 100 is poor. So I am saying poor gets poorer means you will remove the hydrogen from the poor carbon. You will remove the hydrogen from poor carbon, or you will remove the hydrogen from that carbon which is having lesser number of hydrogen atom, Clear ho gaya beta? Okay. So that is why this hydrogen will be released out to give you the major product. Why it is the major product? Because this alkene is more stable. That is a bigger explanation, but hack, a short trick is this: poor gets poorer. Just apply this trick, you will get the right answer. Okay, now understood? Have a look at it. Is this clear? Okay, great. Now let's move ahead. Next is dehydrohalogenation. So dear students, D means removal, hydrohalogen means hydrogen and halogen from alkyl halides. This will also follow the Saytzeff's elimination rule. So you see this Br and this H is being removed out by using alcoholic KOH, and this is the alkene that you get. Okay. Now the question arises, sir, what is this alcoholic KOH? Okay. Now let us finish out this part. एक बार इसको पढ़ लेते हैं, then I'll explain what alcoholic KOH is doing. It will be easier for us. Now you see over here, in this case there are two possibilities. This is rich carbon, this is the poor carbon. Why this is rich? Because 3 hydrogen. Why this is poor? Because 2 hydrogen. So tell me from where the hydrogen will be removed? From the poor one. So this is the major product. Okay. If you remove the hydrogen from the rich one, this is the minor product. So Hoffman's product. Clear है? Clear? जो अभी समझाया था उसका application हो गया? Fine? Okay. Now the next point is the ease of dehydrohalogenation. 3 degree alkyl halide, then 2 degree, then 1 degree. Sir, why 3 degree? Because a 3 degree carbocation will be formed. That is why. Okay. Now, but I mean this is about the carbon. What about the halogen? So 3 degree alkyl iodide, alkyl bromide, alkyl chloride. This is the order of dehydrohalogenation for the various halogens. So these two things are important, they can be asked in the exams. Acha. Now the point, sir, what is this alcoholic KOH is doing? वो क्या कर रहा है? Okay. So you see what alcoholic KOH is doing. See, alcoholic KOH ये क्या होता है? C2H5OH plus KOH. Now see, KOH is a base, so C2H5OH will be behaving as an acid, will give you C2H5O minus K plus water. Okay. Now dear students, this C2H5O minus is called as the alkoxide ion, and this behaves as a strong base. Base का क्या काम होता है? What does base do? Sir, base will abstract the H plus. Exactly. So now okay, this is the compound. So this C2H5O minus, let me write over here, this will take away this hydrogen. Okay. So, this comes up over here and thus this X moves out. Are you getting the point? So, this is the removal of hydrogen and halogen. C2H5O minus ion is a base. Base will abstract the proton. वो H plus को निकाल लेगा. Base will take out the H plus. So, when the H plus moves out, this carbon gets a negative charge. So, it will pass on the negative charge over here to make a pi bond, and then this X minus moves out. Got it? Understood what is the use of alcoholic KOH? Now, instead of alcoholic KOH, a stronger one is sodamide, NaNH2. This is a stronger base. NH2 minus. So, you can use this one also. Okay? Fine. Now, you can ask me over here, sir, ye, how do we know which one is stronger? आपने बता दिया ठीक है, but how do we come to know? देखो, if you are talking about C2H5OH, over here you are having a oxygen hydrogen bond, and here you have this is ammonia, NH2, NH3. Okay. Which is more electronegative, oxygen or nitrogen? Sir, oxygen. So, this bond can be easily broken. Yes, it can be easily broken. So, this is a stronger acid as compared to ammonia. So, this will behave as a weaker acid. Huh? ठीक है बेटा? You have studied the Lowry-Bronsted concept. So, the conjugate base of this will be C2H5O minus, and this will be NH2 minus. So, a stronger acid will have a weaker conjugate base, a weaker acid will have a stronger conjugate base. So, NH2 minus ion is stronger than C2H5O minus. ठीक है? अब आप बोलेंगे, sir, but you are writing this is, बेटा, ethanol is not a stronger acid. Out of these two, it is stronger. Ethanol is not a strong acid. Bhai, people drink it. So, they will die if it is a strong acid. Not a strong acid. Okay. So, it's a weak acid. It's a weak acid, but out of these two, it is stronger. Abhi clear ho gaya? So, alcoholic KOH concept is clear. How it is going to remove out, everything is clear, beta. Samajh mein aaya? Haan? Chaliye, great. So, we are now clear with all these points which are over here, the dehydrohalogenation of alkyl halides. अभी आगे बढ़ जाते हैं हम लोग. Okay? I hope there is no other doubt till now. कोई और doubt आया राजेंद्र जी? Just show it to me if it is there. Okay. Now some important points. In case of 1 degree alkyl halide, RO minus ion does nucleophilic substitution also to form ethers. Okay, so this point I will not elaborate right now. I will elaborate this point when we will be talking about the alkyl halides part. Okay, you just need to remember that in case of 1 degree alkyl halide, the alkoxide ion apart from elimination can also give you a substitution product. बस अभी इतना याद रखिएगा, बहुत जल्दी एक क्लास छोड़ के उसके बाद we will be talking about the alkyl and aryl halides, so no need to worry about it. Okay, ठीक है? By using alcoholic KOH, 1 degree, 2 degree, 3 degree alkyl halides give elimination products. Okay. So that you know, okay. But so you will be getting elimination as well as substitution product. Now let's go ahead. By dehydrohalogenation of vicinal dihalides. So vicinal dihalide means this carbon and this carbon which are adjacent are having this alkyl group. You react it with zinc in the presence of alcohol and you will be getting the alkene. Okay. Next one, electrolysis of aqueous solution of sodium salt of dicarboxylic acid. See, this is the Kolbe's electrolytic method. Okay, the mechanism is just the same as I told you. So, what will happen over here, my dear students? Over here, you will get one free radical over here. This CO2 will move out. This CO2 will move out, and this CH2 will combine to give you ethene. Please remember this process is only for the ethenes. Okay, the one which I am showing over here. Fine. I mean, what I mean to say is that if you are using this acid, wherein you are having this CH2CO and CH2CO, you will get ethene. If instead of this H, I get something else, suppose I get ethyl, and I get a ethyl over here. So in that case, I can get a hex 3-ene also. Okay. So this is electrolysis. The mechanism remains the same. So I am not going to discuss more about it. Partial hydrogenation of alkynes. So this is similar to catalytic hydrogenation. In fact, wahi hai. The only thing over here is that here you use a Lindlar's catalyst. Lindlar's catalyst is a poisoned catalyst. Poison means, see, we are using palladium, and on top of it we are doing poisoning by calcium carbonate or barium sulfate. Sir, why? See, if you remember in the start of the lecture I told you, see, suppose this is palladium. Now hydrogen is absorbed on it. Now what do you want? You want the triple bond to be converted to a double bond, right? So if you have more hydrogens, you will get alkane. You don't want it. So when you don't want it, what you will do is, you will do the poisoning. So this part which I am marking in green is adsorbed by CaCO3 and BaSO4. So very less space is left for hydrogen. So only few hydrogens are adsorbed. So the alkyne will convert only into alkene. Further hydrogenation will not take place. That is why it is partial hydrogenation. Okay, fine. I also told you about the syn addition part, because both the hydrogens are adding from the same side. So it is called as syn addition. And if you talk about the geometrical isomerism, you will get the cis alkene. You will get the cis alkene. Please remember, you will not get trans alkene, you will get the cis alkene. So is there a way to get trans alkene? Yes. What is the way? Now see, if I use lithium in liquid ammonia, which actually will give you LiNH2 and will release out the hydrogen from there, or so that hydrogen will add up to this alkyne, but you will get a trans alkene. Sir, how? How it is trans alkene? Why is it anti-addition? देखो बेटा क्या होता है. Now this is a good question. See, 2Li will release 2 electrons to give 2Li plus. This 2Li plus combines with 2 ammonia molecules and you will get 2LiNH2 plus 2H plus. Okay. So dear students, you are having 2 electrons and you are having 2H plus. ठीक है. So how the reaction will take place? अब इसको देखते हैं. See, so this is RC triple bond Cr. Now the first electron comes and adds up to this carbon. So sir, how? See, this triple bond which you are seeing over here breaks up like this. So when one electron comes from here, this carbon gets a negative charge. So the second electron cannot come from this side, the second electron comes from this side. As a result, you will be getting, इसको बड़े ध्यान से देखिएगा बेटा, please see it. You will be getting a dianion. This is dianion. Now tell me, is it possible for you to keep both the negative charges on the same side? So sir, no, it is not possible. See, this is having a negative charge, this is having a negative charge. See, they should be 180 degree apart. Now when the hydrogens will come, one hydrogen will add from here, one hydrogen will add from here. And that is why it is referred to as the trans addition or anti-addition. And that is why you are getting a trans alkene. Got it? Is this point clear? Okay. So, now you are clear with syn addition, you are clear with anti addition, you are clear with dianion, right? Chaliye, great. Now, we will be talking about the stability of alkenes, as I told you earlier, because the major product is when the alkene is more stable. There we talked about the hyperconjugation, but the actual fact is that the stability of alkene is based on the heat of hydrogenation. Okay. So, higher the heat of hydrogenation, lower will be the stability of alkene. So, what we have observed is that the alkenes which are more substituted are more stable. Okay. So, over here you see this is the least substituted, you are only having the hydrogen atoms over here, then you substitute, then you substitute, then you substitute, then you substitute like this. Okay. Now, when you are talking about this particular part, dear friends, here there are two possibilities, cis and trans. Agreed? Please remember, trans is more stable than cis because of higher symmetry. Because of higher symmetry. So, the order of stability is this. More substituted alkene is more stable because of its lower heat of hydrogenation. Because of its lower heat of hydrogenation. I hope this part is clear to you. Anushka is asking, I think Anushka you are asking about that dianion. Yes, when you add this alkyne to a solution in which you have lithium and liquid ammonia, the electrons basically interact with this triple bond, okay, and you get a dianion. You are not using water over here, you are not using the gaseous phase, you are using liquid ammonia as the solvent. So, you get the dianion over there and then the hydrogens attack from the opposite side and thus you get the alkene. Clear? Okay. So, this is the order of stability. They have asked question based on this, ध्यान रखें इसको, ठीक है बेटा? Fine. Okay. Now, the next is the physical properties of alkene. There are two things which I wanted to discuss over here. First is the melting point and second is the boiling point. So, you see when we talk about the melting point, we are saying that the trans alkenes are having the higher melting point. Why? Because in solid, if you have a trans alkene, they are more symmetrically placed. The crystal is more symmetrical. The crystal is more symmetric. ठीक है बेटा? Okay. Whereas when you are talking about the boiling point, what you observe is that the cis alkene is having the higher boiling point. Why cis alkene is having the higher boiling point? This is so because the cis alkenes have a net dipole moment. So, they basically attract each other by dipole-dipole interactions. So, they attract each other by dipole-dipole interactions. Right, pyare bachcho? Fine. So, this is about the methods of preparation of alkanes, the properties of alkanes and the method of preparation of alkenes and the physical properties of alkenes. In the next lecture, I will be discussing about the chemical properties of alkenes, then alkynes and most probably we will be able to do the aromatic hydrocarbons as well. So, I am expecting to cover up these topics in the next lecture. Let us quickly revise what are the important name reactions we have done: Sabatier-Sandens reaction, Clemenson's reduction, Wolff-Kishner's reduction, Wurtz reaction, Franklin reaction, soda-lime decarboxylations, Kolbe's electrolytic method, right. Then we have talked about the Saytzeff's elimination, Hofmann's elimination, we have talked about the free radical mechanism, right. We have talked about the beta elimination. Fine. These are the important takeaways from this particular lecture. Okay. You can review this lecture in the repeat telecast, right. And as I told you, better do watch our career counseling show. Fine. Also watch the solutions of the JEE main question that we are going to give on the YouTube channel. So this is all from my side for this lecture. Stay tuned, stay healthy because exam time. God bless you. Bye bye.